Bismillahirrahmanirrahim. Welcome everybody in this one on lecture. So last lecture we were discussing chapter 9. Chapter 9 is free or natural convection. So our main aim was to find A's. But here there is no velocity. So ANU here is a function of Grashof number and Prandtl number. Instead of Reynolds number, we will use Grashof number and Prandtl number. So Grashof number equal to LQ or dq rho square g beta delta t by mu square. There is no velocity here, and beta equal to 1 by tf, and other properties you can get from the table. Grashof number multiply Prandtl number. So this is another number. It's called Rayleigh number. Grashof number and Prandtl number. It is Rayleigh number. Grashof number and this is the Prandtl number. Product of Grashof and Prandtl is Rayleigh number. And we see many equations for vertical plane surface, horizontal plane surface, then horizontal cylinder, then a sphere. We have some correlation, and all correlation based on this Rayleigh number or Grashof and Prandtl number based on this. So we'll use this correlation and find A's. Let's do example. A large vertical plate 4 meter high is maintained at 60 degrees centigrade and exposed to atmospheric air at 10 degrees centigrade. Calculate the heat transfer if the plate is 10 meter wide. So vertical plate 4 meter and TS is 60 degrees centigrade. Width is 10 meter width. T alpha 10 degrees centigrade. So now first question is it what type of convection? There is no velocity, so you can assume it is a natural convection. And what is the geometry? Geometry is from vertical plate. Okay, so for vertical plate we have 3 equations. Capital heat transfer if the plate is 10, so Q equal to what? equal to
HA plus minus T alpha.
T minus T alpha. So we know the A. A is, we know the A, 4 into 10, right? We know the TS, 60 minus 10. Only we do not know the age, so you have to find the age. So when you find the age, then you ask yourself the question. First question is it natural or forced convection? So there no velocity, so it is natural. Then geometry is plate, vertical plate. So we have to use the Rayleigh number. Rayleigh number equal to G beta delta T L cube by, so this is Grashof and Prandtl. So the properties you can get from table TF table A4 K equal to 0.0268 16.5 another number beta equal to 1 by TF 308 and Z 9.8. So all all values is here, so you can get the Rayleigh number. M power minus 3 delta T 60 minus 10, so 50. So L mean this vertical distance, so 4. So it is 3.74 into 10 power 11. So it's greater than 10 power 9. So it is turbulent. So this means it is turbulent. Turbulent flow. Then go to the equation. How many equation we have? Vertical plate. So we have one equation, this we have Sarsier and Cho equation. We have this equation also for laminar flow only. So we have three equation. This is the general equation, simple, and then we have Sarsier and Cho equation. Sarsier and Cho equation is big range, 10 power 4 to 10 power 13. So you can apply this one or you can apply this one, both. Anyone is fine. N equal to C R A power N. So for turbulent flow, C equal to 0.1, and n equal to 1 by 3. N equal to C R A N 0.1 3.74 10 power 11 1 by 3 720.7. So A is L by K, here K by L. We know K 0.02685 02685, and L we know for, so H will be around 4.84. Around 4.84. You can use Sarchin and Soap correlation also. If you use Sarchin and Soap correlation, I got is equal to 4.84. If you use this one, I got is equal to 5.4. So there is some difference, but it's okay. You can use either this one or this one. So when you get the H, then you can calculate the Q. Substitute here 4.84. So around 9675 watt.
Doctor,
Hmm.
you will give us the method or we have to يعني, know it by ourselves
Yourself.
based on the more accurate?
Yes.
Which one of these methods more accurate, doctor?
Sarcina so is more better.
Okay.
But if you use this one, is also you will get full mark also. But the Sarcina so is better than the general one.
And doctor, for beta, we will always assume ideal gas, so it will be 1
Yes.
over CF.
Yes. Yes. So always you can say 1 by Tn. Let's do another example here from your book. This important example. Example 9.3. Air flow through a long rectangular duct, heating duct. Air flow. So there is a duct here, rectangular duct channel, and air is moving through this channel. 75-meter wide. So wide is 75.75 meter and 3 meter high. High 3 meter. Maintain the outer duct surface temperature 45 degrees centigrade. The outer surface temperature is 45. So air is moving through this duct and maintaining the surface temperature. That's it. There is no information about the year. Okay, you see, there is no other information about the year. If the duct is uninsulated and exposed to air at 15 degrees centigrade in crawl space beneath of a home, what is the heat loss from the duct per meter of the length? So outside surface temperature is maintaining at Ts and environment temperature is 15, so room temperature is 15, so it is acting as heater, right? Then what is the heat loss from the duct per meter of length? So here there is no information about the airflow, so you don't need to consider anything about the air. But if you consider the duct, how many surface here? So there is two surface on the vertical. This one and then other one. Two surface in the vertical. One surface top, another surface bottom. So Q will be 2QS side from two side plus Q top, Q bottom. Two side, two is S, two is S, is into L, delta T, right? So put a delta T here outside plus Q top, is top, is top, so L into W, L into W plus is bottom, L into W. So Q by L, you can calculate 2 is S plus is TW plus is BW delta T. There we know the delta T, we know W, we know S. Only problem is we don't know the SS, ST and SB. So we need to determine this coefficient when you consider the vertical plate, when you consider the horizontal plate top, horizontal plate bottom. So what surface facing upward, what surface facing downward. So calculate one by one. TF equal to, what is TF? 45 plus 15. 303. Table A4 you can get gamma 16.26 meters per second, alpha 22.4, 22.9, or 6 second K 0.0265, beta is 1 by TF. So here R equal to G beta delta T L cube by Prandtl number. So we can rearrange this equation G beta delta T L cube. Gamma 1 gamma I keep, and another gamma mean mu by rho, right? Gamma mean mu by rho, and Prandtl number means Cp mu by K. So mu cancel. So G beta delta T L cube gamma Cp Cp rho Cp rho by K. So this means Cp rho by K. So we know alpha diffusivity is thermal diffusivity is K by rho Cp. So this equation we can write G beta delta T L cube by gamma alpha. So in solution you can see sometimes they wrote G beta delta L cube by gamma alpha sometimes. So it is same equation, just rearrange. This is just rearrange the equation. If you do not want to rearrange, that is also okay, but do not confuse here. So we can calculate Ra equal to, if you use this equation, gamma alpha 9.8.0033 into delta T 45 minus 15, so 30 L cube divided by 2.62 into 10 power 9 L cube. So for vertical side plate, that is a vertical plate. When you consider the vertical plate, two side plate or two vertical plate, your L will be is 0.3 meter. So RA will be 2.6 to 10 power 9 L cube. So L is L equal to 0.3 now. 2.6 to 10.9 0.3 cube. So it's less than 10 power 9, so it is laminar. Laminar flow. Vertical surface, laminar flow. So vertical surface, laminar flow, this more accurate equation. Suitable for most engineering calculations, relative better accuracy than often. So we can use this equation. N equal to 0.68 plus 0.67 RA 1 by 4 divided 1 plus 0.492 divided PR 9 by 16 4 by 9. So we know RA, then A is L by K. We know L means 0.3. We know K also. What is the K? 0.0265. Then you can get the AC from here. And this AC is vertical plate, so side AC 0.0265, 0.68 plus 0.67 RA 1 by 4 divided by all of this 4 by 9. So use calculator. I got this 4.23 is side. So we got A side. Now A is top, A is bottom. Top surface. When you consider top surface, the hot surface is facing upward. When you consider top surface. So horizontal, for horizontal plate, facing upward, facing downward, heated surface facing upward. This for laminar flow, this for not laminar, this within this range, and this for within this range. So we need to find the RA value first, and for horizontal plate we have to use the characteristic length. The L is characteristic length for a horizontal plate. So L will be S by P L into W by 2 L plus W. So if L very greater than W, then we can write this W by 2. We can ignore the W and W ignored. So L into W by 2L, LL cancels, so W by 2. So 0.75 by 2 equal to 0.375. So R will be 2.62 into 10 power 9, 10 power 9 L cube. So L here now 0.375. So you get 1.38 into 10 power 8. So you got R here. So which equation? 10 power 8. So we'll use what surface facing upward. So we'll use this equation. N equal to 0.15 RA 1 by 3. N top 0.15 RA 1 by 3. So we know the RA, so substitute here. Then H top by K. 0.15 1.38 into 10 power 8 1 by 3. So HT equal to 5.47. So L equal to 0.375, K equal to 0.0265. Then you can get the HT. Now bottom.
Doctor, we can always assume L much greater than W.
Okay, usually always like this. With always get mass less. So you can assume, no problem. Now bottom surface. Bottom surface also L equal to S by P same 0.375 same. So RA will be then RA will be same. So RA will be same because L equal to point same. So RA will be same 1.38 into 10 power 8. But the equation now, when you consider the bottom surface, is different. What surface facing downward? And N equal to this. We have only one equation, and this is the range, RA range, and our RA is within this range. So we can use this equation. N equal to 0.52 RA 1 by 5. So A is bottom 0.52 RA mean 1.38 into 10 power 8 1 by 5. So L equal to 0.375, K equal to 0.0265. So from here ASV, you can get ASV equal to 1.56. So we got all coefficient, then you can get the Q. Q equal to So substitute here. Delta T we know, right? Delta T is 30. Ages we got 4.23. Age T we got 5.47. Age B we got 1.56. W we know 0.75. 0.75. Age equal to 0.3. So everything we know, then you can calculate the Q by L. It is 234 watt per meter. Any question? Any question here? Okay, so thank you very much for attending and practice more, do
Dictator,
more examples. Yeah.
can you repeat how find for top surface?
Top?
Yes,
Top what? Is?
top surface, how to find L?
Is when horizontal surface. When horizontal plate. In horizontal plate, you see the note here, use characteristics length. When horizontal. When only horizontal plate, then use characteristics length. L equal to AS by P. Characteristics length formula L equal to AS by P. So L equal to surface area L into W divided by perimeter. P is the perimeter. So 2L plus W. So this is the equation. Characteristics length C. L. So if L very greater than W, then you can ignore from plus. L plus very tiny. So you can ignore it. But you cannot ignore in the product because very small multiply large number, then is huge impact. But plus has no impact. So you can ignore from down to L. Then W by 2. L cancel W by 2. Okay.
Thank you, Dictator.
So practice more example. Practice also the assignment. Thank you very much for attending.